Okay, first thing we're going to do is take a look at, well, the very first thing is I gave you, or I put online a notes to self. So it looks something like this here. This notes to self is for you to make notes on um, all the important things of the unit will go in here. Okay, and you can make little notes here so you can have this as a little, not cheat sheet, but a check-in sheet. Okay, so first of all, go to that. And a lot of stuff we can put in here today, and I'll review that at the end. Okay, so first things first, before we start talking, um, the first unit we did was about one variable, as in we had one set of data points. This time we have two, so we're going to be looking at like hour studies versus marks, amount of time trained versus skill. Maybe look at like time put in and earnings or things along those lines. So we're looking at two variable items now. And the two things here, the first one here is trend. Oops. Trend, okay? So a pattern of behavior that occurs over time is a trend, okay? Now that's just you're observing something happening over time. Now a correlation is the apparent relationship between two variables. So you're observing the classic teacher one is the how much you study versus grade. And you observe over time, the more you study for a test, the higher grade you get, the less you study for a test, the lower grade you get. So that's the apparent relationship between two variables, and this time would be time and grade. Okay. Now we can discuss this relationship by looking at a scatter plot in two words. One is looking at it through strength. Okay. The other is direction. Okay. So if we look at this, if we have this here as our graph, if we have dots going up, right, direction per se is positive. And if we have something going down, it would be termed as negative. Okay, so that's the first thing, positive and negative, and then all the strengths we discuss are going to be associated with positive or negative first. Okay, so if we look at a strong correlation, the dots on this graph are data points. Okay, so if we were looking at like this would be our grade, and this was time studying, the dots here are close together. We have a line of best fit going through it. The dots are close together. Therefore, we have this be a strong positive correlation because the dots are close together, which equal to strong, right? And then it's going upwards, which is positive. Okay. Now here we have still a positive correlation because the trend of the dots are going upwards. So we'd have a positive correlation. But then we would have weak because the dots are further out. Right? They're spread out and not quite as tight or consistent. So it'd be a weak correlation. Example of this would be like maybe pop cans sold and pop cans recycled. Generally, it's going to go up, but it's not going to be as consistent. Now, this one here, we have a downward line, so it's negative. And the dots are close together, data points are close together, so it's going to be strong. Let's keep going. Here's a weak negative one. We got dots that are further apart and a line going down. So it's weak because the dots are far apart, negative because the line's going down. Now, we could have, I'm going to do here, let's say I take the purple dots. And if they're kind of still spread out, but still closer, that would be a moderate correlation, something that's a little bit closer. Now, no correlation, there's no trend happening. You look at this set of data and you don't know if it's going up, it's going down. So there's no correlation going on. Like, for example, this was like your math grade and the length of hair. Okay? No correlation going on there. We don't know what's going on. There's no connection between the length of hair and your ability to do math. Okay? So if we go through these here, and we label them as a strength and a direction. Okay, so if you look at this one here, first of all, it's negative. It's going downwards. And you draw a little line of best fit here. I'd probably say that was strong. Now later on in this unit, we're going to give a numerical value to strong, moderate, and weak. Right? So if you look this one, I'll give you a couple seconds to see if you can figure it out. The words we're looking for first are positive or negative. Then the strength is going to be strong, moderate, weak, or no correlation. This one here, we still have this trend going up. So it's positive. And I would label that as weak because it's all over the place a little bit. Here, I would have this probably as a no correlation. There's just no trend there. Like I can't draw a line going down or I can't draw a line going up. They both look the same. So I'd say no correlation there. Now, this one here, now correlations don't have to be linear. This one here, you can see it's a curve, right? So I'd say that's a moderate curve. Now we don't have a positive or negative because it's not going up or down, it's going both. You say moderate curve. Here I would say, for me, no correlation. For this one, I would look at that and I'd say, okay, it's positive because it's going up. But I'd also say it's pretty strong. Like if I draw a line there, all the dots are pretty close to it. This one, weak. Weak negative. Here is a strong curve because those line up pretty much perfectly along those lines. So it would be strong. See if I can find my other ones, my other examples. So if I find a moderate one. Here's one here that I would deem as moderate. Right? It's not super close. Like here, I would say this is weak negative. Right? This would be my strong negative. And this would be my moderate negative. You kind of see the difference between them. Strong, we're really close together around the line of best fit. Here, we're a little bit spread out, and here, we're even more spread out. Okay. Now, later on, we'll do a correlation coefficient, which is the numerical value of it. But we can use technology so well now. I'm not going to teach you how to use that because we'd learn how to do it once, and then we would just put it away. So on your notes itself, right now, the things that we covered would be this top part here. What's a trend? What's a correlation? And then you could draw a example of a positive correlation, a negative correlation here. Then we have strong, moderate, weak, and no correlation. And you can kind of make notes on each of them there as well. The second thing we're going to look at today, and you can always pause the video to kind of see it and write it down what we need to. The second thing here is we're talking about independent and dependent variables. So when you're graphing here, which axis do you put everything on? Okay, where does the dependent one go? Where does the independent one go? Now, the way I work this out is I say it out loud. So if we're looking at ice cream trucks here, ice cream truck sales, the independent always goes along the x-axis and the dependent goes along the y-axis. So I would look at this. I would say, okay, do sales depend on the temperature, or does temperature depend on sales? And figure out which one sounds better. And realistically, like the temperature doesn't change due to how much ice cream you're selling, but generally the sale of ice cream will depend on the temperature. You're not going to sell as much right now in the winter as you would in the summer. So sales depends on temperature. So you'd be amazed how many students still struggle in this grade figuring out which is which. So let's do some examples here as I go here. So we'll do a bunch of here. So a study was done to find if different tire treads affect braking distance. So I'd say, okay, does braking depend on your tires, or your tires depend on your braking? I would take the first one as the independent one. So brakes depends on your tires. So tires is your independent and brakes are your dependent. The time it takes to run a mile. Time to run a mile depends on the person's running speed. So does speed depend on time? Or does time depend on speed? In this case, time depends on the speed of the runner. Now, after I read it, pause it, see if you get it right here. The height of the plant depends on the water it receives. Now, these ones are literally giving you the answer. So this one, the height depends on the water. So let's go down to so which one depends on what? Temperature of the water, or what's that here? The depth of the water and the temperature. So does temperature depend on the depth of the water, or the depth of the water depend on temperature? It works out that the temperature depends on the depth of the water. So the amount of pollution produced by cars was measured using gasoline containing different amounts of lead. So we have pollution and lead. Does the amount of lead depend on pollution, or does pollution depend on lead? Well, the amount of pollution depends on the lead. Okay? So you have some practice to get through, and you're good for today. Fill out those notes to self, and then you have some practice identifying correlations, and then some practice identifying independent and dependent. Okay, so go to your notes to self, or whatever sheet you're using for your notes to self, and I want you to write in these steps here. So I'm getting oriented. Okay. So I want you to write in these steps right here. These are the steps that we're going to do today. So pause it right now, write the steps down, and then I'm going to go through it. So step 1, organize your numbers from least to greatest using your X. The Y's come with the X's. Step 2, count the number of points and divide by 3. Step 3 is to organize each of your X and Y's in the grouping from low to high. Then step 4 is find the median for each of the groupings. And then you're going to plot those points. Okay, so what we're doing is we're making a median line. And what a median line does is, if you have a scatter plot and you make a line of best fit, sometimes an outlier will draw your line of best fit either up or down. Okay, and what a median line does is I have a better chart here. What a median line does is it takes the effect of the outlier away and gives you a more true line of best fit. Okay, so that's what we're doing here. So I'm going to, this is going to be a really boring part, I should have done this ahead of time. I'm going to make a scatter plot for this data right here. All right, and I'm going to go up by 10, so hopefully there's 1, 6, 7, 8, 9, 10. I'm going to break my graph. Start at 50, 60, 70, 80, 90, 110, 130, 150, I believe is my highest. 150 is not my highest. 70. I'm going to add a 190 here. Okay. Then up, we got to go to 65, 10, 15. So I'm going to break it here and start at 30, 35, 40, 45, 50, 55, 60, 65, 70. Okay, so we got our X and Y axis here because cost depends on distance. Cost depends on distance. So I'm going to make my scatter plot right now. So I'm going to go 50, 30, boom, 60, 40, 70, 39, 80, 40, 90, 45, 100 and 40, 110 and 50, 120 and 50, 130 and 51, 140 and 55, 150 and 55, 160 and 50, 170 and 60, 180, 60, and then 65. So there's our scatter plot. Okay. And then we would draw a line of best fit. And this always turns out being a horrible line of best fit when I do this, but let's do it anyways. Oh, not bad. So there's our line of best fit for that. Okay. Now, this doesn't have any outliers generally, but I'm going to do one later on with a couple outliers. So we have this here. Now let's make our median line. So the first thing we have to do is we have to arrange our data from smallest to largest using the X component. Now, luckily our X's are already lined up from smallest to biggest. So we're good there. Now, next is we are going to split our data into 3. So let's see how many numbers we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 numbers. So we're going to split our data into 3. 1, 2, 3, 4, 5. There's one set. 1, 2, 3, 4, 5. Other set, just make sure 1, 2, 3, 4, 5. So now we have to find the median of the X's and Y's for each of the sections. So this is going to be my red section. Now, our top X values are already arranged from smallest to largest. So we can pick our median here. So 70 is going to be my X value of my point. But our bottom here is not arranged from smallest to biggest. Let's do that. we have to rearrange our y. So we're going to go 30, 39, 40, 40, 45. Then my median is 40. So what I'm going to do with that point is I'm going to chart that point on our graph, 70 and 40. 70 and 40. So that's my first point of my median line. And then my second one I'm going to do in green. Now it looks like we're in luck because the x values are in order from smallest to biggest, and our y values are as also. So it's 120 is our middle number here, our median number, and 50 is our middle number here. So 120 and 50 is going to be our median point here, 120 and 50, which is right there. I should do all these. I'll leave it. Now this one here, now we luck out again, where our median number is 170 along the x. Oh, and this one here is not in order, but these two are just going to switch. 55, 60, 60, 65. And our middle numbers here of 60. So 170 and 60. 170 and 60 is right here. Now using those 3 points, we do not draw a line that attaches them all. We don't draw that line. We draw a line of best fit using those points. Now this one here is going to look pretty good. Let me grab this. Now it just happens to attach there, but they don't need to go and attach all together. Okay? So let's do another one here. I'm going to make up some numbers. Copy this. Oops. So I'm going to paste. Good. All right. So we can use this chart over again and just ignore the rest of it. And let's do something like this. What data should I do? Let's say let's say we do the classic hours studied and grade. Okay, I'm going to make up some numbers here. One second, my glove I used to write is all messed up and it's annoying me now that I can see it. Okay, so let's say this person went for 3 hours of studying and got an 80. This person studied 5 and got a 90. This person studied for 2 and got a 60. This person studied for 1 and got a 95. Let's say this person got studied for 10 hours and got an 80. This person studied for 8 hours and got a 70. This person studied for 5 hours and got a 80. I'm going to go back and change this one. This one's a little out of whack with the rest of my data, I think. 1, 2, 3, 4, 5, 6, 7. Let's do 2 more. Let's do 6 hours for a 85, and let's do 3 hours for a 50. So there's our data. So let's make a scatter plot. I'm going to go by here, 2, 4, 6, 8, 10. We're going to go by 20, 30, 40. This is going to be really bad. 50. Oops, let's start over. I'm going to break it and start at 50. 50, 60, 70, 80, 90, and 100. Okay, so let's make a scatter plot with this. 3 and 80. Boom. 5 and 75. Boom. 2 and 60. Boom. 1 and 95. Like such. 10 and 80. 8 and 70. 5 and 80, 6 and 85, 3 and 50. All right. So if I were to make a line of best fit with this, it probably looks something like this, taking into account the outlier there. It's probably something like this. Maybe even flatten it out, something like that. Okay. So let's use our median line here to work this out. So the first thing we have to do is we have to reorganize our data using the x values. And the y's come with. So it's going to be 1 and 95, 2 and 60. So I'm going to cross these out so I don't miss it. Now I have 2 3s here. I'm going to put 3 and 50 first. 3 and 50. Because the trend of my data is the longer I study, the higher my mark is, I'm just going to order them as such. And then we have 54s. No, we have 5 and 80 and 5 and 75. So we're going to have 575, 5 and 80. Boom, boom. Then we got 6 and 85. 8 and 70. And 10 and 80. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then we have to split our data into 3. So 3 per each section. Then we have to reorganize our data in our y component. So I'm going to reorganize this to 50, then 60, then 95 for the first section, 75, 80, 80 in the second section, 70, 80, and 85 for the third section. And then we can find our median points here. Our median points for the first section is going to be 2 and 60. 2 and 60. You see how this 1 and 95, like our extremes here, get kind of erased because they're not going to lie in the median of our data. So they're going to be a little spread out. Like we're going to get rid of our extremes as we go, which is going to lie in the median part. So 2 and 60 is going to look about here. Next one is 5 and 80. 5, 80. So I'm going to graph that one. 5 and 80 looks about there. Our last one is 8 and 80. 8 and 80 looks about here. Okay, so now you can see if we make a median line through this, ironically, it almost looks kind of like the line I almost made earlier. And you use Desmos or a computer program to find your exact median line between there. But remember, you're not making this line. Okay, you're making a line of best fit for that situation. I'm going to erase this one so you can see it. So it kind of gets rid of the influence of your outliers on the data. On your line of best fit. Okay, so it kind of takes the middle of everything and kind of makes a common line so we don't have it pulled up or pulled down using a extreme. And now I'm going to do another one just so we have a solid idea of it. If you have it down, you think you're good to go, you're good to go. But if not, let's take a little peek at this again. So let's do a little bit of minutes played and score in basketball. What did you score in a basketball game? Okay. So let's go with, I'm going to set my max as 20 or so. So let's say in a game you played 30 minutes and you scored 10 points. You played 10 minutes and you scored 15 points. You played 25 minutes, you scored, let's say, 18 points. Let's say is one game you played 40 minutes and you scored 30 points. 5 minutes and you scored 10 points. Let's say you played 15 minutes and you scored 15 points. Let's go 2 more. And then let's say you played 20 minutes and scored 18 points. And you played 25 and you scored 15. Okay. I don't know if I made something with a correlation here with a trend. Let me go through my numbers again. I want to get lower as I more. So let's go. You scored 5 points there. Let's say you scored 8 points there. Let's go with that. 25 should have been. Let's go 10 points here. All right. Let's go this one. Let's go 20 points. Okay. So first thing we do is graph it here. So I'm going to go my minutes and score. Minutes need to go up by 5s up to 40. So I'm going to go 5, 10, 15, 20, 30, and 40. The highest points here. I'm going to change this one just for the sake of it to 10 points. That way they all land on 5s. Let's go 5, 10, 15, 20, 25, 30. Okay, so I'm going to make my scatter plot first. 30, 10, 10 and 15, 25 and 10, 40 and 30, 5 and 20, 15 and 15, 20 and 10, 25, oops, oh, it's 225, 25 and 5, 25 and 5, there we go. So, you can see here, this is an outlier. And what would happen is, if I plug this in the Desmos, it would make a line of best fit about there, because it's incorporating that outlier in. Okay? Now, let's make our median line. Now what I'm going to do here is we're going to reorganize our data from small to big. So 5 and 20 are first. 10 and 15, get rid of you. 15 and 15, boom. 20 and 10, 20 and 10, 25 and 10, 25 and 5, and 30 and 10. All right, now my next part is to split the data into 3. And you'll notice here, I don't have a divisible number by 3. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. What number did I forget? 25 and 10, 25 and 10, 40 and 30. This is what I forgot. So 30 and 10, yeah. So 40 and 30. Okay, so I got 1, 2, 3, 4, 5, 6, 7, 8 data points. So if you have 8 data points, what you want to do is you still split into 3, but there's no, what I'm going to do is I'm going to go 2, 3, 3 this time. Now, it would not be wrong to go 3, 3, 2. It wouldn't be wrong going like that. Now, I see but personally I went 2, 3, 3 because I know that this is my outlier here. So if I put it in 2, it would still have an effect on it. So I educationally went, okay, let's not put it there. And I am going to use a 3 to kind of make sure that doesn't affect it. If I had 2, it would draw it up because I'd just be looking at these 2, which I mean I have to put the median between there, which would be 20, which is higher than the trend that I'm seeing. So first things first, split into 3. Next, go high to low. 15 to 20. This one's going to be 10, 10, 15. And then we're good here. Now let's find our points. Now this one here is going to be a little different. In between, because our median is right between these two. So in that case, it's going to be 7.5. And then 17.5 for this one. Because there is no true median number since I don't have an odd number. So it's going to happen between these two numbers. Remember, if I have it, I add them up. And then divide by 2. Now these ones here is going to be 20 and 10. 20 and 10. This one here is going to be 30 and 10. So now when I go to do this, I can go 7.5, 17.5. We're about there. 20 and 10 is right here. And 30 and 10 was my last one, right? 30 and 10 is right here. So now if I were to make a line of best fit using this, it's going to end up about here, which is much better and like a better representation of my dots, of my data points, than the purple one, because the purple one got stretched out by the outlier. Okay? So median line is built to devalue the effect on the outlier on your line of best fit along those lines. One last little thing here. You'll notice that sometimes, like, there's multiple points. Like 5 here had 2 data points, which is perfectly fine. So you just graph them both. Like I graph one there and I graph one there. All right, besides that, I think we're good to go, and have a great day.